You ever stop and wonder about the magic that's running everything these days? Your phone, self-driving cars. There's this powerful secret behind it all. Well, today we're going to pull back the curtain on that secret. We're talking about neural networks, the engines of modern AI. Let's dive in and see how they actually work.
So, to get our heads around this, let's start with something you probably use every single day, maybe without even thinking twice about it.
No, really, think about it for a second. How on earth does your phone know your face and not your friends or your brother's in less than a blink of an eye? It feels like magic, right? But it's not. It's actually a brilliant piece of engineering. And the answer, the whole secret, lies in building a kind of artificial brain. But, one made out of code instead of cells. And when engineers needed to design a system that could learn and spot patterns, where did they look for inspiration? They looked at the most powerful, most complex computer in the entire known universe, the human brain.
Okay, check this out, because the parallels here are just uncanny. Our brains, they have billions of biological neurons, all connected by synapses. A neural network? Well, it has digital neurons connected by pathways that have these things called weights, and they're all stacked in layers. And here's the kicker. Just like we learn from experience, the network learns from data. It's almost like a direct blueprint, just built with code.
So how do these digital brain cells, these neurons, actually work? It all boils down to one very, very simple job.
Yeah, forget about any kind of complex philosophical thinking. At its absolute core, a single digital neuron is just a tiny little decision maker. It's basically a gatekeeper that gives a simple yes or no answer. That's it.
So here's its entire job description, the whole thing. Step 1, it gets some data. Let's say the brightness of one single pixel in a picture. Step 2, based on that input, it makes a super simple yes or no call. And step 3, it just passes that decision along to the next neuron in the chain. That is literally its entire job. Now, on its own, one neuron is, well, it's pretty useless. But here's where the magic happens. When you stack millions or even billions of them together in these interconnected layers, something incredible happens. All those tiny, simple decisions suddenly add up to something unbelievably complex and powerful. And this is what it's all for. You see, the first layer of neurons might just recognize simple things like little edges in a photo. The next layer takes those edges and starts to see shapes like an eye or nose. Then the layer after that puts those together and recognizes a face. See how that works? Each layer builds on the last, turning millions of tiny yes-no votes into one big, complex answer. Okay, so the structure kind of makes sense, right? It's like building with Legos. But how does it get so smart? How does it actually learn to get the answer right? And this right here is the most important question. I mean, having a brain structure is one thing, but actually making it learn, that's the real challenge. It's not like someone programmed it with all the right answers from the get-go. The answer is surprisingly simple and very, very human. It learns by getting things wrong. Over and over and over again. We're talking billions of times, at a speed and a scale that is just mind-boggling. So how exactly does it learn? It all comes down to this idea of weights. Okay, so picture the connection between every single neuron. Now, imagine each one has a little volume dial on it. When the network makes a mistake, like say it sees a picture of a cat but calls it a dog, it goes back and slightly adjusts thousands of these little dials. It turns some up, turns others down, just tweaking things to make it a tiny bit more likely to get it right the next time. And this creates this constant, powerful learning loop. It's just guess, check the answer, adjust the dials, guess again, check again, adjust again. This simple loop is what makes these things so unbelievably powerful. See, with old school programming, a human had to write every single rule. With a neural network, it discovers the rules all on its own. It just repeats this process billions of times with mountains of data. And with every single cycle, it gets a little smarter, a little more accurate, until, bam, it can pick your face out of a crowd, no problem. All right, so now that we've got the basic idea down, let's bring it back to the real world. Because, and I promise you this, once you know what you're looking for, you start seeing this stuff everywhere. And this isn't some far-off science fiction concept. This core idea, this learning network of digital neurons, it's already woven into the fabric of our daily lives.
Think about it. That face unlock on your phone? That's a neural network. A self-driving car staying perfectly in its lane? That's a network analyzing video in real time. When you talk to Siri or Alexa or chat with one of those AI bots, you're talking to a neural network. When your phone's camera magically makes your photos look better, yup, neural network. Even your bank is using them right now to spot fraudulent transactions by recognizing patterns that no human ever could.
And really, that brings us to the key takeaway from all of this. We haven't built a machine that truly thinks like a human does. Not really. What we've built is a machine that is an absolute expert at one thing: learning from data. The real magic isn't that they can think, it's that they can learn.